All right, we're going to graph linear inequalities. So back in the day, we were just graphing regular inequalities like x is less than 4 or y is greater than or equal to 6, and you had a dot on the number line and you shaded right or left. This is similar, except we're going to have like y is greater than or equal to 5x minus 2. So we've practiced with the lines already, so it's very similar to that, but instead of having a dot and shading right or left, since this is like two number lines, we're going to either shade above or below that line. So just like with the solid or filled in or open dot, it's similar with the type of line. So if it is less than or greater than, you're going to have a dashed line or a dotted line. Instead of like when we were doing inequalities before, it was an open dot, meaning it wasn't part of the solution. If it's got the or equal to's, it was a filled in dot back in the day, and here it's going to be a solid line because it is part of the solution. And then as far as the shading, it's kind of intuitive. If you can get it in the slope-intercept form, if you have greater than or equal to, greater than, your brain thinks like above, right? So you would shade above the line. If it's less than or equal to, you shade below the line. It has to be in slope-intercept form for that to work every time, which that's the only form we currently know how to graph. So y is less than or equal to x plus 2. We'll just graph it like it's just equals to. So you would start at 2, go up 2, you make a dot, and the slope is 1, so you go up 1 over 1. So this is a solid line because it's less than or equal to. So we're going to make a nice solid line here through all these dots. Oops. And it says it's less than or equal to that. So that would be shading everything below that. So when we were just doing the systems of equations, we were looking for one coordinate that worked for both of the equations, right? All of these things that are shaded, any coordinate that is shaded would work with this inequality. So like over here, 5, 0 is a solution. You can substitute that in for x and y, and it'll work out to be true. Even this point right here, because it's a solid line, it is included there. So that point would be 0, 2. If you substitute that into the original inequality, that works as well. So the shaded things are solutions to the inequality. Let's try another one. Y is less than negative 2x. Slope or y-intercept is 0, and the slope is negative 2. So you go down 2, right 1. If you wanted, you can go up 2, left 1, but that could get a little dicey. Just be careful. Now this one is just less than. So this one will have a dashed line or a dotted line, however you want to say it or think about it. Because these numbers on the line, these are not included in the solution. So if it's on the line here, it doesn't work in the original inequality. But this one says less than, so we would shade everything below that line. That would be all this stuff. So these coordinates I just shaded in green, these all work in the original inequality. Anything on the line will not work. Anything above the line will not work. So I have 3 that I'd like you to try. So go ahead. Let's make sure these are all pretty friendly. So go ahead and pause here, try graphing them, and then check in when you're done and see if we got the same thing. Down 1, then we'll go up 3 over 1. Solid line. And it is greater than, so we shade above. Okay, here up 3, our slope is negative 1. Dashed line. And this one is greater than, so we shade above the line. And the last one, start at negative 4, and have to move over. Slope is 2, up 2 over 1. Dotted line, and this one is less than, so we would shade below that line. That'll show up in a minute. I guess not. I broke everything. Again, the shaded areas are coordinates that work in the inequality. Ooh, word problem, fun. Apricots, or if you're cool, apricots, cost $3 a pound. Tomatoes cost $1 per pound. You plan to spend no more than $10. How many pounds of each can you buy? So I set the labels here. You could really set them however you'd like. But I have apricots as the X's and tomatoes as the Y's. So let's assign a value to each of these X's. How much were the apricots? They were $3 a pound. So we would say 3X plus, let's talk tomatoes. Tomatoes were $1 a pound. So 1 times Y, or we can just say Y. I gotta move down here. It says we spend no more than $10. So what inequality could go with no more than? Could it be $10? Sure. Could it be over $10? No. So it has to be less than or equal to 10. So we need to get this into a form we're familiar with. And currently that would be slope-intercept form. So we'd have to get rid of that 3x by subtracting 3x from both sides. So our new equation, our new inequality would say y is less than or equal to negative 3x plus 10. So our y-intercept here would be 10, and then our slope would be negative 3. So let's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's go 1, 2, 3, 4, 5. And that'll be enough for this one. So we would start at 10, and our slope is negative 3, so we go down 3 over 1, down 3 over 1, down 3 over 1, and then the next one would go off of our graph. So this is a solid line. And by the way, the only reason I gave you just the top right quadrant of the graph is because you can't buy negative tomatoes or negative apricots. Now it has to be less than or equal to this, so it would be everything under this line. So all of these would be possible combinations that you can get of tomatoes and apricots. How many pounds of each can you buy? Well, tomatoes we could buy 10 pounds. Tomatoes would have to be less than or equal to 10 pounds. And then apricots. Now this goes beyond 3 over here, so we could say less than or equal to 3 pounds of that. And it could be any combination in the middle here. So you could say, well, we could get 1 pound of apricots and 5 pounds of tomatoes, and that would be fine, right? Which if you calculate that, 1 pound of apricots would be $3, 5 pounds of tomatoes would be another $5, so that would take us to $8, right? So all kinds of combinations available there. Now we're gonna do a system of linear inequalities. Same thing, we're just gonna have 2 of the graphs with 2 shadings, and then where the shadings overlap, that's gonna be our solutions for both of them. So I'm gonna move this over. Y is greater than X. Well, that one has a y-intercept of 0, slope is 1, and this would be a dashed line. And it's greater than, so we would shade everything above this line. Now it's hard for me to shade with overlapping colors on the board, but if I was doing this on paper, I would just shade this pretty lightly. Now we'll graph the other one. Y is less than or equal to negative x plus 2. So go up 2. Our slope is negative 1, so we go down 1 over 1. Now we're not just looking for where they intersect each other, like we did with the systems of equations, because it was one single solution. Here we're going to have multiple solutions. So let's see. This is a solid line, and it is less than that, so we would shade everything below this line. So the solutions for both of these, the system of linear inequalities, is which area of the graph has shading for both of them. And if you look, this left section over here, this is where they're both shaded. So this would get shaded really dark on your paper. And anything I just shaded in red here, any of these coordinates work for both inequalities. They're solutions for both inequalities. So I want you to try. We'll do one more together, and then I'll have you try the other one. Let's scoot these up. We will do A together, and then I'll have you guys try out B, see how we do, and then that's the last slide. All right, negative 2x minus 5. We start down 5. The slope is negative 2, so we can go down 2 over 1. Now, if we want to go backwards, we can go up 2 left 1 to make sure we're on the graph. And this is a solid line, and it's less than, so we would shade everything underneath this line. Now we're going to graph the second one. 1/2 x has a y-intercept of 0 and a slope of 1/2, so up 1 over 2 or down 1 left 2. We got a dashed line on this one because it's just less than, and when it's less than, you shade below. So again, we're looking for where are they shaded, which would be this bottom middle section. So these are all solutions to both inequalities. So try out B, pause it, check back in, and see if we get the same stuff. All right, x minus, go down 1, slope is 1. This would be a dashed line. And it is greater than, so that would shade everything above that line. Second one, 3x plus 4, go up 4. Slope is 3, up 3 over 1, or down 3, left 1. Again, a dashed line. And less than on this one would be below. So they are shaded together in this B right here. Sweet. Cool. We did it. We graphed linear inequalities.